something I want to jump into now is how to use the calculator for the through fastened products. Something you'll note in our calculator is there's nowhere to enter a through fastened product. Let me get to another page where I can show you. We'll go back to those load test results of the bracket products. So I can take this information, the Versa Bracket 47, ultimate in a wood deck. Let's go with a steel purlin. The ultimate load is 1,282 pounds. I'm going to jump back over to my calculator, and we're going to start another. You know what? I'm going to go back. And I'm going to use that same job we were working on. So I'll go into my project list, which I didn't show you before, and you can see, yeah.
The question is, when we test in two load directions, normal and parallel, and the question is, what does it mean when you say it's normal?
So here on the landing page for the load test results, you'll see here it says pulling load parallel to seam. In this diagram, you can see where we're basically showing the load with the arrow. So when we're testing, we're pulling parallel to the seam for the holding strength. When you get into pulling load normal, you can see we're pulling in an upward direction.
So normal load is an engineering term that just means perpendicular to the surface of the panel.
So I jump into my projects. I see my project right here that I've already started. I'm going to open it back up. We're going to add a new roof. Now, on most of those through fastened products, the seam spacing you're going to change. It's going to be your major rib spacing. I'm going to set 12 here for this case. Now the manufacturer we would say is AB Martin Roofing, but we're going to bypass all of this manufacturer product and thickness information. And I'm going to click this button that says manually enter load value. It's because I don't have any of this data in the calculator. We're going to manually enter it. So now it wants to know that ultimate load value, which I've pulled from the load table on the Versa Bracket 47, which is 1,282 pounds. Then it asks for a description. What I always put here is Versa Bracket steel purlin, so that I remember what load values I used. You can select here for a clamp. I'm going to choose other clamp. Something else to point out is on any competitive product that they can give you test data on, you can use this to also calculate and do a comparison from a competitive product to our systems to see how many parts you might need per panel. And I didn't mean to select that. We'll select other S5 clamp. The seam height would be the height of the Versa clip. The vertical versus horizontal should not really matter there. Same answers. Safety factor 2, snow clips yes, bottom row, Versa clips. Now we can name this one. I'll name this one shed just so we have a name on it. And calculate. So now even though we didn't have that profile in our calculator, we knew the load results and we can test for what we need. It's going to tell me, I don't know why this defaults to S5U, but you would change that out with Versa Bracket because that's the product we're using. We have a design vector of 510 pounds per panel with an allowable load of 965. Gives us one row of assembly with a clamp on every seam. Now you note that it's 510 pounds and we have an allowable of 965. So something I may want to do on this because of the major rib spacing, I may want to change this and say, well, let's see how far we can spread it. So I'll come back to my clamp information, and instead of this 12 inches, let's say this one has major ribs every 8, and we'll jump it up to 16. We can hit calculate, and we're still going to stay with our one row of assembly, but we widen our spacing so we don't have to use as many parts.
Jump it up to 24. Jump it up to 24 and see what happens.
We end up with a design vector of 1,020 pounds per panel. So therefore it tells us we need 2 rows of assembly, and our service load goes back down to 510.